Let us start with remaining part of descriptive statistics, that is measures of dispersion, जिसे हिंदी में अपकिरण की माप कहते हैं, and other parts are measures of symmetry, that is skewness, and measures of pigness, that is kurtosis. Measures of dispersion or variability, विषमता या अपकिरण की माप ही मेजर्स ऑफ डिस्पर्सन कहलाता है। जैसा कि पहले अभी हमने आपको बताया, मेजर्स ऑफ सेंट्रल टेंडेंसी विच मेजर्स द मिडिल मोस्ट वैल्यू ऑफ अ सीरीज, यह इसे केंद्रीय प्रवृत्ति की माप भी कहते हैं। परंतु यदि जब आंकड़ों में बिखराव, डिस्पर्सन और स्प्रेडनेस और स्कैटर्डनेस इन द डेटा इज हायर or more, then mean will not be a true representative of the data. In that situation, we measure the dispersion or variability of the data. The dispersion of distributions reveals how the observations are spread out or scattered on each side of the center. Center is the middlemost value is called the measures of central tendency, that is mean, mode or median. Mean के लेफ्ट और राइट साइड में आंकड़ों का बिखराव कितना है, दैट वी हैव टू मेजर थ्रू द मेजर्स ऑफ डिस्पर्सन. इफ द डिस्पर्सन इज स्मॉल, इट इंडिकेट्स हाई यूनिफॉर्मिटी ऑफ द ऑब्जर्वेशंस इन द डिस्ट्रीब्यूशन. अगर जो डिस्पर्सन है, अगर उसकी वैल्यू इफ it is small, which indicates that the data is highly uniform. If the dispersion is high, it indicates the data is not uniform. It means the observations are highly scattered. And absence of the dispersion in the data indicates perfect uniformity. This situation arises when all observations in the distribution are identical or similar. If all the observations are identical or similar, then the measures of dispersion will be 0. Let us take an example. Student first got marks in 5 subjects are 68, 75, 65, 67 and 70, and second students also got in 85, 90, 80, 25 and 65. If we calculate the average, total marks are 345 obtained by each of these. Some of the first student's marks are 345, while the second student marks are again 345, and mean marks equal to 345 divided by 5, that is equal to 69. The average marks obtained by both the students are 16 marks. But here we see that the student second, who got 25 marks out of 100, and he is treated as failed because 50% are the passing marks, and average marks are 69, but a second student is failed in one subject. So that the mean would not be a true representative of the data, and we have to calculate the dispersion of the data, and 25 is far away from 69, that is average. Take another example. एक और एग्जाम्पल हम देखते हैं. दो प्लेयर्स हैं. एक प्लेयर क्रिकेट में 3 इनिंग में एक में 0 रन्स बनाता है, सेकेंड इनिंग में अगर 50 रन्स बना रहा है, और थर्ड इनिंग में अगर वो 100 रन्स बना रहा है. और इफ़ वी एवरेज ऑल दिस 3 innings runs, that is 0 plus 50 plus 100, that is 150, sum of all the runs divided by 3 innings divided by 3. So average runs per inning is 50. Another player who is making runs 48, 50 and 52 runs in 3 innings, means in first inning he made 48 runs, second inning he made 50 runs, and third inning he made 52 runs. And average of all these 3, 48 plus 52 plus 50, that is again 50 runs. Both the players having same average runs in 50 in each inning, but player first having spreadness of the data is very high. In the first inning he made 0 runs, while in the third inning he made 100 runs, and second in 50. And second player made 48 runs in first inning, 50 runs in second inning, and 52 runs in third inning. Then spreadness of the data of first player is higher than the second player. Second player is more consistent than first player. If we have to select a player for further matches, we will select player second because he has very less spreadness, he has a very less scatteredness of the data, or he is more consistent than the first player. Let us take another example, measures of dispersion and comparing standard deviations. Data A, data B and data C, there are three sets of data here, and we see 11 comes one time, 12 comes one time, 13 comes one time, 14, 15 are 0, 0, and 16 comes two times, 17 comes one time, 18 comes one time, 19 and 20 are 0, and 21 comes one time. There are 8 observations, 1, 2, 3, 4, 5, 6, 7, 8. Summation F is 8, and if we calculate the arithmetic mean, that is 124 divided by 8, that is 15.5. In this case, standard deviation is 3.338. I will show you how to calculate the standard deviation after some time. And data B, here we see the data B. 11 is absent, 12 is absent, 13 is absent, 14 having 1 frequency, 15 having 3 frequency, 16 having 3 frequency, 17 having 1 frequency, and 18, 19, 20 and 21 having 0 frequency. Here again mean is 15.5 and standard deviation is 0.926. In case of data C, 11 having 3 frequency, 12 having 1 frequency, 13, 14, 15, 16, 17, 18 having 0 frequency, they are absent, and 19 having 1 frequency, 20 having 3 frequency, and 21 having 0 frequency. In this situation, mean is also 15.5, but the standard deviation is 4.570. Here we compare the mean of all the three data sets are similar, that is 15.5, 15.5 and 15.5, but the standard deviation of data B is quite less than data set A and data set C. Standard deviation of data set B is 0.926, while data set A 3.338 and data set C having a standard deviation 4.570. It means spreadness of the data is more higher in A and C than data set B. And here we see that the standard deviation is higher, means spreadness in the data is higher. If standard deviation is low, it means spreadness in the data is less. Less spreadnet data are more reliable, while more spreadnets in the data is less reliable. We can say purpose of measuring dispersion. A measure of dispersion serves two purposes. First, we characterize a frequency distribution. हम distribution को characterize कर सकते हैं. Second, comparison between two or more frequency distributions. हम two or more frequency distributions में compare कर सकते हैं. Two distributions have same averages but substantial differences in their variability obtained only by measures of dispersion. Variability in the distribution can be measured by measures of dispersion. These are the various methods of measures of dispersion. First one is absolute measures of dispersion and second is relative measures of dispersion. Under the absolute measures of dispersion, first is range, second is mean deviation, third is quartile deviation, and fourth is standard deviation and variance. While in case of relative measures of dispersion, first is the coefficient of range, second is the coefficient of mean deviation, third is coefficient of quartile deviation, and last is coefficient of variation or coefficient of standard deviation. Both are same. Coefficient of standard deviation is same as the coefficient of variation. What is range? It is the simplest measure of dispersion. Difference between largest and smallest values of the data. Range is equal to largest value of the data minus smallest value of the data. Let us take an example. Calculate range and coefficient of range of the data. Here we are calculating both absolute measures and relative measures. These are the data 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 and 13. The range is lowest data minus highest data. Lowest data, largest data is 13 and smallest data is 1, that is 13 minus 1, that is 12, and coefficient of range is L minus S upon L plus S. L is the largest is 13 minus 1 divided by 13 plus 1, that is 0.85 or 85%. The range coefficient of range is 85% or 0.85. It is a relative measure, that's why it doesn't have any unit. But in case of absolute measures like range or mean deviation or quartile deviation or standard deviation, the unit are same as the data sets. While in case of relative measures, they are expressed in the terms of percent variation. Range can be misleading. Ignores the way in which data are distributed. The data are 7, 8, 9, 10, 11 and 12. Range is 12 minus 7, that is 5. The data are 7, 10, 11, 12. 12 minus again 7, range is 5. If the data sets are 1, 1, 1, 1, 1, 1, 1, 2, 2, 2, 2, 2, 2, 2, 3, 3, 3, 3, 4 and 6, range is 6 minus 1 is again 5. And sensitive to outliers. If the highest data is 120, that is 1, 1, 1, 1, 1, 1, 2, 2, 2, 2, 2, 2, 2, 2, 2, 3, 3, 3, 3, 3 and 4 and 120. The largest data is 120, smallest data is 1, that is range is 119. The range is sensitive to outliers. If the observations are extremely high or extremely low, then the range will not be a true representative of measures of dispersion. It will mislead us. Second number, what are quartile division? Quartiles split the range data into 4 segments with an equal number of values as per segments. Q1 having 25% data, Q1 to Q2 having 25% data, Q2 to Q3 having 25% data, and Q4 fourth quartile having 25 data. The first quartile Q1 is the value for which 25% of observations are smaller and 75% are larger. Q1 से 25% डेटा वो छोटे होते हैं और 75% बड़े होते हैं. Q2 is the same as the median. 50% observations are smaller and 50% observations are larger, and only 25 of the observation greater than the third quartile Q3. This is Q3 से जो है only 25% observations are greater than the third quartile. Second, interquartile range or quartile deviation. IQR, interquartile range, IQR or quartile deviation, QD and coefficient of quartile deviation, CQD. The IQR is defined by Q3 minus Q1. It is the difference of third quartile minus first quartile. Measures the spread in the middle 50% of the data. The IQR is a measure of the variability that is not influenced by outlier or extreme values. If in the beginning or at the end, if the outlier observations, they are not taking part in the measurement of the variability in IQR. Quartile deviation is the average difference between Q3 minus Q1 divided by 2. And quartile deviation is what? Q3 minus Q1 divided by 2 or IQR divided by 2. Measures like Q1, Q3 and IQR are not influenced by the outlier are called resistant measures. Q1, Q3 and IQ are not influenced by outlier observation, that's why they are called the resistant measures. And coefficient of quartile deviation equal to Q3 minus Q1 divided by Q3 plus Q1. If you want to express in the percent, then we multiply this value by 100 also. Let us take an example. calculate the interquartile range and quartile division. First, we calculate the quartiles Q1, Q2, Q3. And the sample data are 11, 12, 13, 16, 16, 17, 18, 21, and 22. Here, the number of observations are 9. And Q1 is n plus 1 divided by 4, that is 2.5. That is second plus third divided by 2, that is 12 plus 13 divided by 2, that is 12.5. Q2 is equal to 9 plus 1 divided by 2, that is the fifth observation, that is 16 divided by 16. Q2 is the 16, that median is 16, and Q3, that is 3 times of n plus 1 divided by 4, that is 7.5 position of the rank data, that is 7th position is 18 and 8th position is 21. 7 plus 8 divided by 2, that is 18 plus 21 divided by 2, that is 19.5. That is Q1 is 12.5, Q2 is 16, and Q3 is 19.5. Q1 and Q3 are the measures of non-central location, while Q2 is equal to measure a median is a measure of the central tendency. Calculating the interquartile range. Interquartile range 19 minus 7 minus Q3 minus Q1, that is 19.5 minus 12.5, that is 7. Quartile division is equal to Q3 minus Q1 divided by 2, that is 7 divided by 2, that is 3.5. And coefficient of QD is equal to Q3 minus Q1 divided by Q3 plus Q1. That is Q3 plus Q1, that is 7 divided by 32, that is 0.21. The box plot and whiskers diagram. A box plot is a graphical representation of the data, and we may prepare the box plot from these data, that is Q1 and that is Q2. We make a box like it at Q2. We divide this box, and 25% data are here and 25% data are here, and these are the whiskers. This is a way of presentation of the data through box plot diagram, box and whiskers diagram. Here the smallest, that is 21, and these lowest whisker goes up to 11, and the largest, and this right side whisker goes up to largest value, that is 22. And we make the box like this from Q1, Q2 and Q3. We make a box, and that box contains 25% data. Here this is the median point, and this is the 25% data are also here. Second, mean deviation. What is mean deviation? Mean deviation of a series is the arithmetic mean of the deviations of the various items from a measures of central tendency, either by arithmetic mean or median or mode. Mean deviation in case of individual series. Mean deviation from mean, where x bar is the mean, then mean deviation from mean is represented by delta x bar, and that is summation of mod x minus x bar divided by n. As we know, x minus x bar and sum of x minus x bar is always 0. If we make sum of the modulus values of x minus x bar, means all negative values becomes positive and positive also becomes positive, then we find out the mean deviation from mean by taking the modulus of negative and positive values here, and that is the mean deviation from mean, that is delta x bar. Mean deviation from median, first we calculate the median from the data and subtract all values from the median, and taking sum of mod values, negative values, and divided by n, then we get the mean deviation from median, that is delta m. Mean deviation from mode, that is delta z represented by, and delta z can be calculated by this summation of mod of x minus z divided by n. First we calculate the mode from the series, and then we subtract mode from each of xi values and take the sum of all negative and positive values as a positive and divide the sum by n, then we get the delta z. What are the coefficients? Coefficient of mean deviation. Coefficient of mean deviation from mean, that is delta x bar divided by x bar, means mean deviation from mean divided by general mean. Coefficient of mean deviation from median, that is delta median divided by median. Coefficient of mean deviation from mode, that is delta z divided by z. Here is some typographical mistake. This is delta x bar, this is delta md, and this is delta z. Example, let us take an example in case of individual series. Calculate mean deviation from mean and median for the following data. The observations are 100, 150, 200, 250, 360, 490, 500, 600, and 671. Also calculate coefficient of MD. Here we calculate mean as x bar is equal to summation x by n, and sum of all these observations are 3321, and these observations are 9, that is mean is 369. Now arrange the data in ascending order: 100, 150, 200, 250, 360, 490, 500, 600, 671, and median value, that is n plus 1 divided by 2, because the number of observations are odd, that is n equal to n. 9 plus 1 divided by 2, that is the fifth item will be the median. Here the fifth item is 1, 2, 3, 4, 5, then 360 is the median of this data. We already calculated mean and median. Now we calculate the mean deviation from mean and mean deviation from median. That is x minus x bar, and that is x minus md. 100 minus 369, that is 269, minus 269. If we take the mod value, that becomes plus 269. 150 minus 369, that is 219 with negative sign. After modulus sign, it becomes 219. 200 minus 369, that is 169 with minus sign, and this minus 169 having this mod sign, then it becomes 169. 250 minus 369, that is minus 119, and after mod minus 119, that it becomes plus 119. 360 minus 369, that is minus 9, and after mod minus 9 becomes it plus 9. 490 minus 369 is 121. 500 minus 369 is 121. 600 minus 369 is 231, and 671, that is 302, and the sum is 1570. 369 is the mean and 360 is the median. If we subtract 360 from each observation, that is mod of x minus md. 100 minus 360, that is minus 260, and after mod minus 260, it becomes plus 260. 150 minus 260, that is 360, that is 210, and minus 210, after mod minus 210, it becomes plus 210. 200 minus 360, that is minus 160. Mod of minus 160, that is plus 160, and so on, and the summation of mod of x minus md, that is 1561. First we calculate mean deviation from mean, that is summation of d or summation of x minus x bar, that is 1570 divided by 9, that is 174.44. Coefficient md is equal to md divided by x bar, that is 174 divided by 369, that is 0.47 or 47%. Mean deviation from median, that is summation of mod of x minus md divided by n, that is 1561 divided by 9, that is 173.44, and coefficient of md is equal to mean deviation from median divided by median, that is 173 divided by 360, that is 0.48. You see here mean deviation from mean is 174.44, coefficient of mean deviation from mean deviation is 0.47, mean deviation from median is 173.44, and coefficient of mean deviation from median is 0.48. Thus we calculate these values like this. Mean deviation in case of discrete or continuous series. Only change in the formula in frequency, and mean deviation from mean is delta x bar is equal to summation f mod of x minus x bar divided by summation of f. Summation f is nothing but sum of all the observations. Mean deviation from median md is equal to delta m is equal to summation of f x minus md divided by summation f, and mean deviation from mode z delta z is equal to summation of f mod of z x minus z with mod sign divided by summation of z. Example of discrete or continuous series. In case of discrete or continuous series, uh, uh, in case of continuous series, the class intervals are given 0 to 10, 10 to 20, up to 70 to 80, and these are the mean values or mid values of the class intervals. If we hide this class interval, then the example becomes the example of discrete series, and if we are having the class interval, then this example becomes the example of continuous series. These are the corresponding frequencies, total 212. D is equal to m minus a upon c, and this is minus 3, minus 2, minus 1, 0, 1, 2, 3, 4. This is the step deviation method. And fd, this is f frequency and this is d. Minus 60, minus 50, minus 32, 0. 1 into 42 is 42, 2 into 35 70, 8 into 4 is 32, total is 32. D is equal to m minus x bar. M is 5, and what is x bar? X bar is equal to a plus summation fd upon n into c, that is 35 plus 32 divided by 212 multiplied by 10, that is 36.5. Mean is the 36.25, and mean, if you subtract 5 minus 36.5, that is 31.5, with minus sign becomes plus signs. 15 minus 30, 36.5, that is mean. 15 minus 36.5, that is 21.5, with minus sign, that it becomes positive sign. It is also minus 11.5, it becomes positive. It minus 1.5 become positive, and this is 8.5, 18.5. These are the all summation of m minus x bar. This is summation of fd. If we multiply these d with corresponding values, 20 into 31.5, that is 6.630.0, 25 into 21.5, that is 530. This comes around 3193 divided by 5. Substituting the value in this form, mean deviation from mean, that is summation of f d is nothing but this is summation of x minus x bar, and that is f we multiplied, and this is 3193, and number of observations are summation f is 212, that is 15.06, and coefficient of mean deviation is equal to mean deviation from mean is 15.06 divided by 36.5. This is the coefficient of mean deviation from mean, 15.06, and coefficient of mean deviation from mean is 15.06 divided by mean 36.5. Calculate the median and mean deviation from median from the following data. This is mf, this is the cumulative frequency, and after calculating the cumulative frequency 212 divided by 2, that is n by 2. N by 2 is 106. 106 belongs to cumulative frequency 117, then 40 will be the median class, and 30 to 40 will be the median class, and this is the median frequency. Here we calculate L is equal to 30, M is equal to 7, median class frequency is 40, and C is the 10. If we calculate median by this formula, L is equal to n by 2 minus m upon f into C, and median comes around 37.25. If we subtract these values from m minus d, that is mid value 5 minus 36.25, 37.25, we get 32.25. These values after getting negative sign, we are getting positive after this mod sign, and we multiplied this mod d values by a corresponding frequency. 20 multiplied by 32, 645, 22.25 multiplied by 25, we got 556.25, like this, and this is the summation of f mod D, that is 3209. This is coefficient of mean deviation from mean. Then this is the mean deviation from mean median, that is summation FD divided by n, that is 3209.5 divided by 212, that is 15.14, and coefficient of mean deviation is equal to mean deviation from median divided by median, that is 15.14 divided by median is 37.25, that is 0.41. Merits and demerits of mean deviation. It is simple to understand and easy to compute. It is rigidly defined. It is based on all items of the series. It is not much affected by the fluctuations of sampling. It is less affected by the extreme items. It is flexible because it can be calculated from any average. It is better measure of comparison. Demerits, it is not a very accurate measure of this because all negative values becomes positive. It is not suitable for further mathematical calculation. It is rarely used. It is not as popular as standard deviation. Algebraic positive and negative signs are ignored, is mathematically unsound and illogical. These are the demerits of mean deviation. Sample statistics versus population parameters. As I have already discussed during last lecture, population parameters mean mu is represented by mu. Sample statistics statistic mean is represented by x bar. Variance sigma square in case of population parameter, while in sample statistic variance is represented by s square, standard deviation by small s, and population parameters variance is represented by sigma square and standard deviation by sigma. Fourth measures of dispersion is a standard deviation in case of individual series. It is defined as the positive square root of the arithmetic mean of the squares of the deviations of the given values from arithmetic mean. The squares of the standard deviation is also called variance. In case of ungroup data, we can calculate the standard deviation. Let x1, x2 up to xn be n observations of the standard deviation. Then the standard deviation of the is given by this formula. SD is equal to summation of 1 by n, summation of xi minus x bar ka whole square divided by n, where arithmetic mean is equal to summation of xi upon n, and n is the number of observations. Or standard deviation, after simplifying we get the formula. In case of this formula, we don't calculate the arithmetic mean x bar. We have simply have the value of x values and their x square values, and using this formula we simply find out the standard deviation, that is 1 by n summation of xi square minus summation of xi ka whole square divided by n, that is total 1 by n with square root sign. And by this formula we have to calculate only the x values square and sum of the x values only. Standard deviation is the positive square root of the mean square deviations of the observations from their arithmetic mean. And in case of population standard deviation, sigma is equal to under root sign summation of xi minus mu ka whole square divided by n, where mu is the population mean. In case of sample observation, if observations are less than 30, that is s is equal to summation of xi minus x bar upon n minus 1, that is x bar is the sample mean, and SD equal to under root of variance, or square of SD is called the variance. Population SD, that is summation, after simplifying the formula, summation xi square minus summation x ka whole square divided by n, that is equal to summation of x minus mu ka whole square divided by n. And in case of sample standard deviation, summation x square minus summation x ka whole square by n upon n minus 1, it was simplified by this formula, summation of x minus x bar ka square divided by n minus 1. Measures of dispersion, sample standard deviation calculation. How to calculate the sample standard deviation? Here, sample data are 10, 12, 14, 15, 17, 18, 18 and 24. And here the number of observations are 8 and mean x bar is equal to sum of all the observation, that is 128 divided by 8, that is 16. 16 is the mean. Subtracting the mean from each of the data, that is s is equal to square root sine 10 minus 16 square plus 12 minus x bar ka square plus 14 minus x bar ka square up to 24 minus x bar ka square. Putting the value of x bar is equal to 16, we have 10 minus 16 square, 12 minus 16 and 24 minus 16 square. After calculating these value, we got 130 divided by 7, that is 4.3095. These 4.3095 represent a measure of the average scatter around the mean. जो मीन हमने 16 फाइंड आउट किया है, इसके आसपास जो है, जो स्केयर्ड एवरेज स्कैटर्डनेस ऑफ द डेटा इज 4.3095. इट इज अ मेजर ऑफ स्प्रेडनेस ऑफ द डेटा या मेजर ऑफ scatteredness of the data around the mean. The weight of 5-year heads of sorghum are 100, 102, 118, 124, 126 grams. Find the standard deviation. These are the x values: 102, 100, 102, 118, 124, 126. Sum is 570. What is x square? That is 100 square is 10,000. And 102 square is 10404, square of 118 is 13924, and square of 124 is 15376, square of 126 is 15876, and this is the summation x square, that is 65,580. As per the formula of standard deviation, we know that s is equal to summation of x square minus summation x ka whole square divided by n and whole divided by n minus 1. Here are the number of observations are 5, 5 minus 1 becomes 4, and summation x square is 65,580, summation x square is 570 square divided by 5. After solving this, we have under root 150, that is 12.25 gram. That is the standard deviation is 12.25. In another example, 10 families having number of rooms. Find standard deviation of ungroup data. Here the data are given and there looks like a discrete series, but this series is not a discrete series, it's a individual series, and this is the ungroup data. These are the family numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and these are the number of rooms available with the family. That is first family having 3 rooms, the second family having 3 rooms, third family having 4 rooms, fourth family having 4 rooms, fifth family having 5 rooms, sixth family having 5 rooms, seventh family having 6 rooms, eighth family having 6 rooms, ninth family having 7 rooms, and 10th family having 7 rooms. Here summation of xi by n, that is plus 50 divided by 10, that is 5. Average rooms per family are 5 rooms. 5 rooms per family is the average, and we find out the x minus x bar. Then subtracting the mean 5 from each xi values, 3 minus 5 is minus 2, 3 minus 5 minus 2, 4 minus 5 minus 1, 4 minus 5 minus 1, 5 minus 5 is 0, 5 minus 5 is 0, 6 minus 5 is 1, 6 minus 5 is 1, 7 minus 5 is 2, and 7 minus 5 is 2. And this is summation of x minus x bar is always 0 because it is the property of the mean. Sum of all the deviations taken from their mean is always 0, and that is summation of xi minus x bar square. Square of these value, minus 2 square is 4, minus 2 square is 4, minus 1 is 1, minus 1 is 1, 0 is 0, 0 is 0, 1 square is 1, 1 square is 1, 2 square is 4, 2 square is 4, and summation of x minus x bar square is 20. That is s square is equal to summation of x minus x bar square upon n minus 1, that is number of observations are 10 minus 1, that is 9, that is 20 divided by 1, that is 2.2. This is the variance. If we take the square root of this root 2.2, that is 1.48 is the standard deviation of the data. These are the data, and 5 is the arithmetic mean. This is the 1.4 the average scatteredness of the data from this mean 5. This 1.48 shows the average scatteredness or average spread of the data from the mean 5 is 1.48. What is standard deviation in case of discrete or continuous series? Let f1, f2 up to fn be the n frequencies corresponding to the values of a discrete series or mid values of the classes of continuous series, that is x1, x2, xn respectively. Then the standard deviation is given by s is equal to square root sin summation of fi xi minus x bar ka square divided by n, and where x bar is equal to summation of fi xi divided by summation of fi. In case of discrete or continuous series, we may calculate the arithmetic mean from this formula, and after simplifying this formula we will have standard deviation s is equal to summation fx square divided by n minus summation fx upon n ka whole square. Let us take an example. Find the standard deviation of group data in case of discrete series. This is the xi values 3, 5, 7, 8, 9, and this is the fi value 2, 3, 2, 2, 1, 0. Fi xi means 2 into 3 is 6, 5 into 3 is 15, 7 into 2 is 14, 8 into 2 is 16, 9 into 1 is 9, and total is summation fi xi is 60, and x bar is equal to summation of fi xi divided by summation fi, and the summation fi is 10, that is mean or average is 6. What is fi xi square? After squaring the x values, 3 square is 9 and 9 2s are 18. 5 5 25, 3s are 75. 7 7 is 49 and 49 into 2 98. 8 8 is 64 multiplied 2, that is 128. 9 9 is 81 multiplied by 1, that is 81. That is summation fi xi square is 400. And xi minus x bar is what? Xi values are these, and x is 6, 3 minus 6 is minus 3, and 5 minus 6 is minus 1, 7 minus 6 is 1, 8 minus 6 is 2, 9 minus 6 is 3, and xi minus x bar ka square, that is 3 minus 3 square is 9, minus 1 is 1, 1 is 1, 2 is 4, 3 is 9. Fi into xi minus x bar square, multiplying these xi minus x bar square with corresponding frequencies. 2 into 9 is 18, 3 into 1 is 3, 2 into 1 is 1, 2 into 4 is 8, 1 into 9 is 1, total 40. What is s square? Is equal to summation of fi xi minus x bar square upon n minus 1, that is 40 divided by 9, that is 4.44 is the s square, and after square root of 4.44 we get the standard deviation of the series. Find standard deviation of the group data in case of discrete series. The frequency distribution of seed yield of 50 seasonal plant are given below. Find the standard deviation. Seed yield in gram 3, 4, 5, 6, 7, and number of plants are 4, 6, 15, 15 and 10. First, these are the x values and these are the x square values. This is the corresponding frequencies, and this is the fx. 3 4 is 12, 4 into 6 is 24, 5 into 50 is 75, 6 into 15 is 19, and 7 into 10 is 70. And this is the fx square. This is the f, and these are the x square value. 3 square is 9, 4 square is 16, 5 square is 25, 6 square is 36, 7 square is 49. And what is fx square? 9 into 4 is 36, 16 into 6 is 96, 25 into 15 is 375, 36 into 15 is 540, and 49 into 10 is 490. That is summation fx square is 1537. What is standard here? N is 50, and standard deviation s is equal to summation fx square by n minus summation fx upon n ka whole square. That is 1537 divided by 50. Summation fx square is 1537, and n is 50 minus summation fx by n 271, that is summation fx divided by 50, that chi square, and after solving this we get 1.1677 gram. This is the standard deviation, and 1.1677 grams. Find standard deviation of grouped or continuous series in case of continuous series. The following data of 381 soybean plant height in centimeters collected from a particular plot. Find the standard deviation of the plants by direct and deviation method. These are the plants at 6.8 to 7.2, 7.3 to 7.7, 7.8 to 8.2, 8.3 to 8.7, 8.8 to 9.2, and so on. That is last is 12.3 to 12.7. Number of plants, this frequency is 9, 10, 11 up to 7. Solution. This is the formula to calculate standard deviation. S is equal to square root sign summation of f x minus x bar square divided by n. X bar is equal to summation f I x I by n. And after solving this formula, we have summation of f x square by n minus summation f x by n ka whole square. Or if we take common from n, and here we have 1 by n, that is the remaining term is summation of fx square minus summation of fx ka whole square divided by n, that is square root sign. This formula we may also use. This is the same formula, this is also the same formula. Class intervals are given here. These are the frequencies, these are the mid values of the class intervals: 7, 7.5, 8, 8.5, 9, 9.5 up to 12.5. And these are the fi into xi. If we multiply by this xi value corresponding with fi values, we have 63, 75 up to 87.5. fi xi square, after squaring the value 7, 7, 49, 49 into 9, that is 441, 7.5 square into 10, that is 562, 8 into 8, that is 64, multiplied by 11, that is 704. Squaring of each observation xi values multiplying with corresponding fi value, we get these values. And these are the n, that is total number of items, that is 381. This is the summation of fi xi, that is 3793.5, and summation of fi xi square is 38346.25. Putting the value in the formula, and we use the formula 1 by n summation of fi xi square minus summation of fi xi ka whole square divided by n, and x bar is equal to summation fi xi divided by summation fi. And arithmetic mean is 9.96 centimeter, and SD is equal to 1 upon 381 bracket summation of fi xi square, that is 38346.25 minus summation of fi xi ka whole square, that is 3793.5 ka whole square divided by 381. And after solving this, we get 1.23 centimeter standard deviation in the plant height of these soybean plants. Combined standard deviation. Just like combined mean, we can also calculate the combined standard deviation of two or more series. If a series of n1 item having mean x1 bar and standard deviation sigma 1, and another series of n2 items has mean x2 bar and standard deviation sigma 2, we can find out the combined mean and combined standard deviation using the formula. Combined mean we can calculate by the formula x12 bar, that is n1 x1 bar divided plus n2 x2 bar divided by n1 plus n2. And combined standard deviation we can calculate by this formula sigma 1 2 is equal to square root sign n1 sigma 1 square plus n2 sigma 2 square plus n1 d1 square plus n2 d2 square divided by n1 plus n2, where d1 is equal to x1 minus x12 bar and d2 is equal to x2 minus x12 bar. This is x12 bar is the combined mean, and x1 bar is the mean of the first series, x2 bar is the mean of the second series, and while sigma 1 and sigma 2 are the standard deviation of first and second series. Another formula we have sigma 1 2 is equal to square root sign n1 sigma 1 square plus n1 x1 bar minus x12 bar square plus n2 sigma 2 square plus n2 x2 bar minus x12 bar. Here we placed in this formula d1 and d2. d1 is equal to x1 minus x12 bar and d2 is equal to x2 minus x12 bar. And here we have x12 bar is the combined mean of both the series. Calculate combined SD or standard deviation from following data. Particulars regarding income of two villages are given below. Number of people in village A are 600 while in village B are 500. Average income is 175 in village A and while average income in village B is 186. Standard deviation of income is 10 in village A and standard deviation of village B is 9. Compute combined mean and combined standard deviation of the data. Given n1 is equal to 600, x1 bar is 175, sigma 1 is 10, n2 is equal to 500, x2 bar is 186 and sigma 2 is 9. Combined mean we can calculate by this formula x12 bar, that is n1 x1 bar plus n2 x2 bar divided by n1 plus n2. That is n1 is 600, x1 bar is 175, n2 is 500, x2 bar is 186 divided by n1 plus n2, that is number of people village A are 600 and village B are 500. After solving this, we get the combined average income of both the villages 180 rupees. Combined standard deviation, that is sigma 1 2 is equal to n1 sigma 1 square plus n2 sigma 2 square plus n1 d1 square plus n2 d2 square, where d1 is equal to x1 minus x12 bar, that is x1 bar is 175 and x12 bar is 180, that is minus 5, and d2 is equal to x2 bar minus x12 bar, that is 186 minus 180, that is 6. Putting the value in the formula, that is sigma 1 2 is equal to n1 sigma 1 square, that is 600 into sigma 1 is 10, that is village first 10, that is 10 square is 100 and 2 is 5 square and sigma 2 square, that is 9 square is 81 plus 81 plus 600, that is n1 into d1 square, that is minus 5 square is 25 and n2 is 500 into d2 square, that is 6 square is 36 divided by 600 plus 500. After solving this, we get 11.02, that is the combined standard deviation of both the villages income is sigma 1 2, which is represented by sigma 1 2 is equal to 11.02. Coefficient of standard deviation or coefficient of variation. The coefficient of variation is obtained by dividing the standard deviation by the arithmetic mean and multiplied it by 100. And coefficient of variation expressed by this formula sigma upon x bar multiplied by 100. Coefficient of variation is also known as coefficient of standard deviation. Both are the same. Coefficient of standard deviation and coefficient of variation both are same, that is sigma upon x bar multiplied by 100. Let us take an example. Prices of the particular commodity in 5 years in 2 cities are given below. Prices in city A are these and prices in city B are these: 2022, 2019, 23 and 16. The prices in city B are 10, 20, 18, 12 and 5. These are the prices and denoted by X. City A prices and city B prices are denoted by Y. That is X is equal to this value and deviations from X bar, that is total values are 100 divided by these observations are 5, that is mean is 20, and subtracting each value by 20, 20 minus 20 is 0, 22 minus 20 is 2, 19 minus 20 is minus 1, 23 minus 20 is minus 3 and 16 minus 20 is minus 4. And what is dx square? That is 0, 2 square is 4, minus 1 square is 1, 3 is 9 and 4 square is 16. Prices of city B, that is 10, 20, 18, 12, 15. The summation y is 15 and 15 divided by 5, that is 75 divided by 5, that is 15 is the average prices of city B, and subtracting y bar from each y, 10 minus 15 is minus 5, 20 minus 15 is 5, 18 minus 15 is 3, 12 minus 15 is minus 3 and 15 minus 15 is 0. Squaring this y minus y bar, minus 5 square is 25 and 5 square is 25, 3 is 9, minus 3 is again 9 and 0 square is 0. So these are the summation x is 100, summation dx is 0 and summation dx square is 30, summation y is 75 and summation dy square is 68. Putting the value in the formula, x bar is equal to summation x by n, that is 100 upon 5, that is 20, and sigma x is equal to summation of x minus x bar square divided by n, that is summation dx square by n, that is 30 divided by 5, that is root 6, 2.45, and coefficient of variation of x, that is sigma x upon x bar, that is 2.45 divided by 20 into 100, that is 12.25%. Variability in the prices of a commodity in a city A is 12.25%, while city B having y bar, mean prices of the commodity is summation y by n, that is 75 by 5, that is 15, and sigma y is equal to summation y minus y bar square upon n, that is summation dy square upon n. Putting the values, summation dy square is 68 divided by 5, that is root 13.6 with the square root fine, that is 3.69, and putting the value to calculate the coefficient of variation of y, that is sigma y upon y bar into 100, that is 3.69 divided by 15, that is multiplied by 100, and it comes around 24.6%. Thus, we see here the coefficient of variation A in city A is 12.25%, while coefficient of variation of city Y is 24.6. Thus, we say that city A had more stable prices than city B because the coefficient of variation in city A is quite less than city Y. City B, that is city A coefficient of variation 12.25% and city B coefficient of variation is 24.6. Then city A had more stable price than city B because the coefficient of variation is less in city A. Merits and demerits of standard deviation. It is rigidly defined and its value is always definite and based on all the observations and the actual signs of deviations are used. As it is based on arithmetic mean, it has all the merits of arithmetic mean. It is most important and widely used measures of dispersion. It is possible for further algebraic treatment. It is less affected by fluctuations of sampling and hence stable. It is the basis for measuring the coefficient of correlation and sampling and regression and so many statistical methods. Demerits, it is not easy to understand and it is difficult to calculate. It gives more weights to extreme values because the values are squared up. As it is an absolute measure, variability